to my workshop. My name's Darren. We're going to spend a lot of this episode over at the router table because I'll be showing you how to build one of these, and of course at the end I'll show you a couple of the different cuts that it can do. And what this is a router sled. One designed to run in a mitre slot. As you can see, there are runners underneath. A little bit different from your standard coping sled which runs against the fence. This can do a couple of cuts that one can't. Let's go and have a look at how it's made, and like I said, at the end we'll have a look at some of the cuts that it can do. So the purpose of a router table sled is to allow the user to guide pieces of timber past the router bit when they're on edge like this, when there isn't a lot of bearing surface here to run against the bit and you're highly likely to twist as you go past. Even with the fence in place, it's easy to tip into the opening as you go past. So a router table sled has a fence on it, like so it can hold the piece of timber square for the length of its travel, all the way past the router bit and out the other side, and is usually clamped in place to stop it from slipping. Now there's a couple of different ways I could do this. I could do a standard coping sled where the plate here runs right against the fence. The advantages of that are, as we slide the fence back away, we can follow it on, but of course there's only so far we can do that because we don't want to go past the router bit for coping cuts. We will, however, want to go past the router bit if we want to do dado cuts. But the problem with the coping sled style that runs against the fence is we can't do dados, because if we slide it over to do a dado in the centre of a piece, for example, or partway along the workpiece, we will cut through our sled itself. So I'm going to use this track here, that's what it's for after all, and I'm going to have the plate run like so. And that'll allow me to move the fence out of the way and cut wherever I want. It'll always be here, of course, but I can extend the timber as needed to cut where needed. Now there's a few different ways you could clamp your workpiece to the router sled. So my original thought was to have a fence here and mount toggle clamps to it for clamping the wood, but not a very versatile method. Doesn't have a very far reach for wider pieces of wood, but certainly would be limited pretty much to the height of the fence then. So I've decided to go a different way. I'll still have a fence at one end, of course, like I say, it'll be bigger than this. Okay, so I contemplated using T-bolts in the slots, and I've got this bit that would accommodate T-bolts, but it does leave the wood a little bit more fragile. Where you cut, of course, you've then got these little pieces of timber just hanging straight over that are easily pulled out by the T-bolt if you over tighten it. But you know, it's still a workable solution. It also makes the wood somewhat thinner and more prone to breakage. So I've decided to use the match fit dovetail system. A similar problem in that you've got a router channel for it to fit into. This time we're going to use a dovetail bit, and because the sides are sloped they're a little bit stronger. You're not just pulling down onto empty air, you've sort of got something a few degrees behind it. But the downside is that these have a 3/8 or 9.5mm depth of cut, which basically means my timber needs to be close to 20mm thick. This is only 12. If I was to route this at the depth it needs, as you can see, I'd be left with only one ply to hold the thing together. So I'm going to have to use thicker timber. So this is the piece of timber I'm going to use. It's a piece of plywood, but it's sealed on both sides, which should help it slide along a little bit better. As you can see, it leaves me a good 4 ply of timber left after I've run this router bit through it. I am going to cut this piece of timber slightly smaller. I want it to hang over the edge of the router table a little bit to give me a bit of outboard support. Okay, so this is how we're going to set the whole thing up. I've put in my router bit with the largest diameter, and that is so I can set the board up against there and not have it go past this point, otherwise it's just going to get chewed up as it goes past the router bit. There will be a sacrificial fence later as part of this project, but that will get eaten, the base will not. Here I've made some little runners to go in the mitre slot to run everything on, and I will make these available for download. There's a couple of little lumps on one side, just tiny ones, and they're just to take out any wiggle in the slot as it moves along. And the reason I've done it that way is because they'd be very easy to adjust. So if this is too tight for you, you can just file or sand these down and you will get the right fit. Alright, so they're going to sit in there like so, and this will sit on top, just grazing the edge of the router bit there, just slightly. There we go. And I've got some overhang at the edge here, and that will support our work as it's clamped to the unit. So the first thing to do is to chop this down to size over at the table saw and make a nice fence for it. And then we need to fix these runners at the bottom. Okay, so I've got my router bit adjusted for its 3/8 of an inch depth of cut, or 9.5 millimeters. Okay, that's the dovetail slots all routed. Let's see how they go. Yeah, nice, okay. So now we've got to worry about the guide rails and the back fence. There's two reasons I've gone all the way through. And the first is, quite simply, it's easier than it is to do a stopped run. But the other one is, I want to be able to get right up under the fence if necessary, and if I have to, clamp things to the top of the fence, which this will allow. Or, conversely, come in from this side. Now it'll stop when it hits the fence, but it'll allow me to come in over the top of the fence. So that's why I've routed all the way through to the other side. First of all, note it's unplugged from the wall as well as been turned off. Bye bye plug. It's very important that I keep this router sled square to, well, I know bits around, but keep this square to this and square to the fence. All needs to be squared together. So I'm going to use my Mitre square, another Incra product. I'm not trying to flog you Incra, but anyway, there you go. And I'm just going to use that to make sure this is square. I've already tested this and the fence against each other, and they're beautiful. So what I'm going to do is just butt that up against there, and that's the spot where I want this to sit. So now I'm going to take that out of the way. Okay, so with that positioned hard against the fence now, what I'm able to do is remove the Mitre guide here, and then I can pop my little red guides in and attach the two, knowing that it's square up against the fence. Ordinarily these red sliders would sit below the surface of here if just dropped in, because the idea being that when they're screwed to the board they won't actually touch the bottom of the track, therefore it will reduce the friction. But in order to raise them up high enough initially so we can attach them to the board, I've popped a couple of washers in, like so, and I'm just going to pop this down on top of there, and that, as you can see, raises this up perhaps a little bit too high. That will allow us to attach it to the bottom of our board with a little bit of glue, and then we can flip the whole thing over and put some screws in. Right, so these are called self-centering drill bits. They're often used for hinges, but they'll be ideal for what we're trying to do here. So let's do that. Okay, so that's got our pilot holes drilled. These are just some 6-gauged 20mm countersunk screws. That's it, and so I just want to make sure they're recessed below the height of the plastic here. There is countersunk holes in them, so they will do the trick nicely. And this is the sort of tension you want. You want it to be easy to push and pull back. Actually, I can do that one-fingered, so that's nice and easy. But you don't want it to twist. And so the next stage now is to put on our fence. So let's do that. So this is the fence nearly finished. It'll go on there, of course. What I'm going to do before I do mount it onto the board is I'm going to run a dovetail groove down through the center there, So if I want to, I can attach my sacrificial fence to this via screws. I was originally thinking of just coating this in sandpaper, but I thought, well, that'll wear fairly quickly. I want something that's replaceable. So if I can screw my sacrificial fences to little dovetail pieces, but now of course the important thing is to get a dovetail slot in here and get it mounted on this board nice and square. It is a fairly short fence, it's under 50mm, it's 45mm, and that was to allow for bolts that are going to hold these handles on. I say handles, I'm contemplating only doing one now. And as for the placement of the handle, I'm trying to keep it in line with the T-track somewhat, and I think that would give me the ideal pushing position, because keep it nice and straight, push it in a nice straight line. As you can see, I've drilled a recessed hole, and the recess is deep enough to bury the head of this particular bolt. But you can see there's a square section at the base that will dig in once it's tightened from the other side and sort of cut into this wood, if you like, around the hole, the inner hole, and stop it from spinning. Alright, to get this bolt situated initially so as that square bit can dig in, and because my handles that I built have very, very tight thread, what I'm going to do is I'm just going to pop on 2 washers here. And initially I'm just going to use a bolt to tighten that other screw head up. There we go. And doing this will pull the square bit in at the back. So now that head won't rotate. It's nice and tight. I can take that back off and screw on my nice red 3D printed handle. So this is my sacrificial fence. It's quite simply just a piece of plywood with a couple of countersunk holes and an M4 bolt through. And on the other side of the M4 bolt, I've got these little dovetail pieces. Okay, there we go. You can see these are a dovetail shape, narrower at the bottom than they are at the top. And there's an M4 tapped thread in there, or actually it was printed that way, 3D printed that way. And so these simply slide in here on the front face. And then with an Allen key just tighten it in place there like that. Easy. Alright, and that's my sacrificial fence installed. You can see it sticks over the edge of the board, and I'll probably have it stick over even further in use, to be honest. And the idea being now I can undo the screws, slide it forward as needed. When that's worn out, I can slide it forward a bit more and then eventually just replace the whole thing without it ever affecting the main fence. I can take this off, of course, if I want something up against the main fence, or if I want to put some sort of clamp in the main fence. The same principle as the dovetail key in here that holds the fence on, I've utilised here, and again, this time I've got a countersink for the screw, but otherwise there's an M4 thread in there to stop the screw from falling back out. That comes up through a little curved shaped block I've made, and we've got a little thumb screw at the top. And so that's one sort of little clamping system I've got. I've also made up, I've got 2 of those, one for either end. I've also made up a small version of one of these little screw toggle clamps, which actually works. I was surprised because I thought it would be too small to do anything, but no, it does work. And of course, most importantly, I can use these match fit clamps, which is really what it is designed for in the first place. Now I do have to say that Microjig makes something very similar to this indeed, almost identical. Their ends are a slightly different shape, their threads are metallic, they have little metal inserts in them, but the principle is certainly the same. So yeah, there's nothing groundbreaking here. After all, sliding dovetails are older than anybody. They've been around for a very long time. So I don't think I'm breaching anybody's copyright by making my own. These little guys hold down wood surprisingly well. Let's say for argument's sake I was working on this piece of timber. Let's say I was having it that way. After all, these are more suited to thinner timber. So you just butt the curved edge up against here, raise it slightly and screw this fella down. And now what it's doing is it's actually pushing towards the fence and down at the same time. The downside of it is, of course, it's only doing it on the very corner of the timber. You'll know how good a grip that is? Watch this. There we go. That's how well they're gripping that piece of timber, just those two clamps. I'm holding the whole jig from that thin piece of wood. Okay, so let's have a look at just a couple of the joints it can do. And I'll just move those bits out of the way. So I've already set her out a bit to the height I'm after, which is to just skim away here a little bit. And now I'm going to pull my fence out to the same length that we're going through there, and that'll reduce our breakout. Alright, so I'm just going to tighten up our fence. Voila! There we are. That's the lovely neat little tenon there, and in plywood. So it's a tenon jig. I promised you dado, so let's do a dado. Alright, so it'll do dados. Now ordinarily, if I wanted to use a profile bit like this along the edge of the piece of timber, what I would do would be quite simply pop in one of these metal little pins like that, register my piece of timber against it, and then push on through, keeping the wood against the bearing, passing through, doing both sides. But what if I wanted to go all the way around? What if I wanted to do the end? Well, that's just not safe. That's really not safe. I'm sure many of you have done it without hurting yourselves, but that doesn't make it safe. Okay, so I've just loosened off the sacrificial fence, so what I'm going to do is I'm going to bring that out until it just hits the bearing. There we go, that's just hitting the bearing there, and that is going to be the extent of our piece out we're cutting as well, because we want it to run along the bearing. But what we do is we bring that up to the same distance, so that's just, as you can see, hopefully. We're going to clamp those in place. There we are, that's not going anywhere now. Let's double check that they're even, they are. Yeah, we're still just touching the bearing. Alright, so now what we would do is we're going to raise the bit up a little bit each time until we've cut the pattern we want in the end. And action! And there we are, we've got the pattern now routed into both ends very nicely. No breakout or tear out because we had the backing board. Alright, so now what we would do, we would lower the blade using this as a guide to get it to the same height. Ideally you'd use a little bit of scrap, but we've only got the one. Pop our pin in and do the sides. And now what we've got to do is we've got to lower this to the same height that we've got that. That's not so hard actually. That would be easy without the pin in. There we go. All right, so I'm going to lock that in place, lock underneath. We can pop the starting pin back in place. There we go. So as you can see, they've matched up if they've gone around the corner there. There's no issue with that. And it's so much safer on the fingers. So that's a great way of doing that. Alrighty, that brings us to the end of another episode. Now, as normal, I will make the plastic parts available for you to download. I will have the links in the description of the video. Hopefully that's been of some help. Have a great day, and I will catch you in the next video. Bye for now.